It's only a live session, so I don't have any slides. So here I'm going to speak today about how to enrich your postal addresses with the Elastic Stack. And let me take an example. Let's say that you have those kind of addresses. So those are addresses in France. My dataset is in France, but you can apply that to wherever it is. So you have that kind of addresses with a number, the street name, the city and the country, but you don't know how to put that on a map because you don't have the latitude and longitude points. And the other way around, let's say that you have a customer who is in the city, maybe, and you want to know where is his exact postal address or what is the closest address to him. So you have the location point here, but you don't have the street name and all those things. So the purpose of this session is to show you how we can do things and manage that with Elastic. By the way, this is my repository. This is where you have all the demo. If you want to repeat that yourself, then you can just check out this repository. There is all the things inside. So who does not know Elastic yet? Okay, some of you. Cool. So Elastic is basically the company behind Elasticsearch, and Elasticsearch is a search engine. It's a distributed search engine. You send JSON document over a REST API, and then Elasticsearch is going to index the content. Whatever the size of the data you can have petabytes of data, and it's going to retrieve the data in milliseconds or hundreds of milliseconds or what have you. On top of that, you have Kibana. Kibana is the UI, is the window on Elastic Stack, where you can ask Kibana for questions. You can also communicate with Elasticsearch manually, like you have a developer console, and this is what I'm going to use today a lot. And then we have an integration layer, which is mainly composed of what we used to call bits, or now we say agents, but we still use bits here, and Logstash. So bits are agents that you put on a machine, and they are starting to stream the data that you have on this machine and send that to Elasticsearch, and then you can visualize that into Kibana. And if you have an advanced use case, you can also use Logstash to do enrichment, maybe lookups in another database for your events. So Logstash is an ETL. So we are going to use all those 4 tools today for the demo. I will be running everything on Elastic Cloud here. What's the name? Yeah. So let's start. So in France, we are super lucky because there is a project named BANO. BANO stands for National Address Database, something like that. And this project is getting all the addresses that you have within what we call departments, which stands for region, I would say, in France, and they are producing a CSV file every day for all the region that we have. Those data are coming from OpenStreetMap, for example, or from some other sources, but we have this data set. So if I look at what we have, I have already downloaded everything here, and if I'm looking at one of the data, let's say where I'm living here. Can you see that? Yeah, okay. So what I have here, I have an ID, I have the street number, the street name here, the zip code, the city name, the source of the data. So this one is coming from OpenStreetMap and this one is coming from something else. I don't know what it is. And then the latitude and the longitude points. Okay, so this is what I want to actually use for my data set. So I do have something, so let me show you here, curl sample, what's the name? Raw sample. So here I have, I'm taking just the first address that I have in that list, and I'm sending that to curl JSON, which is going to do something. So let's call this one curl raw sample. Okay, something happened. We don't know what, but if I look here in the other tab, I'm seeing something. So I'm going to clean this a bit, and I'm going to run that again. And here I can see that in debug mode here. So I have some information. So this is a JSON log. It's sometimes hard to read, but here I can see that something has been received here, and this is exactly the line that we are seeing. Okay, so actually what I have here, I have FileBit running. So FileBit is listening to something. So how did I set up this thing? Let me show you. Oh, I have this here actually. So here I have my FileBit configuration. And what I did, I just started the endpoint, HTTP endpoint, using the default port. And what I'm doing here, I'm basically listening to the message which are coming from the HTTP interface. And then, as the output part, I'm sending that to Elasticsearch in an index named BanoTest, using a pipeline. We are going to cover that just later, named Bano. Okay, so BanoTest and Bano. So let me show you how I actually started FileBit. Where is that? It's here. So here I'm running on cloud. So basically what I'm doing, I'm using Docker here to run the FileBit image. And I'm mounting also the data dir where I have my Bano data. Remember this, where I have all the CSV files and my configuration for FileBit and all the things that I'm needing here, right? So this is how I'm running that. So let's go to Elasticsearch. So here I'm in the dev tool in Kibana, and what I can do is to run this query. So within the index name BanoTest, I'm just calling the _search endpoint and running that. So I have 2 hits. Yeah, I run the command twice, and here is what I have. So this is the document which is going to be indexed as is. As you can see, this is the JSON document that I have. I have a lot of data that I don't need because those are coming from FileBit. Those are the metadata from FileBit. So I don't need the host, I don't need the input, the agent, the timestamp, the ECS version. I don't need that. But on the other hand, I need the message, but I don't need the message as is. Because if I'm just indexing that into Elasticsearch, I won't be able to say that the end of this line is actually a geopoint, and so coordinates. So what I need to do, I need to change a bit the way my document is injected into Elasticsearch. So to do that, we can use what we call ingest pipeline. So you will find that in the management part here of the stack. Here, if you go to stack management, and then here you will see the ingest pipeline. And I have a pipeline. Remember that when I was calling FileBit, I defined a pipeline named Bano. And this is exactly this pipeline that I have here. So let me open it. It's empty, meaning that it does not do anything, right? So I need to manage it. I'm going to edit it. So what I want to do, what is a pipeline? So the pipeline is taking the document which is incoming into Elasticsearch, and it's going to transform that on the fly before actually indexing that into Elasticsearch. So let's do that. We are going to first start with a processor. So a pipeline is made of processors, and the first one I want to use is the CSV processor, obviously, because I want to extract from the message field some fields. So the fields that I have are the ID. That was the first. I want to indexed the next one in address.number, which means that I will have an object named address and a subfield named number. Same goes for address.street name. I want then address.zip code. And then I have the city name, address.city. And then I have the source, which was OpenStreetMap or something else. And then the location point, so the latitude, and then the longitude. Okay. So I can add this processor. Okay, it's here. What I can do now is to actually test my pipeline. So to do that, I'm going to get this hit, the first one here, and I'm going to copy paste that here in add documents. So I will see what is the effect of my pipeline of this sample document. So run that. So what I can see here, I still have the fields here that I don't need, but here I have this address, then I have the zip code, the number, the city, the street name, and the location, longitude, and latitude, right? I still have the message and the source as well. Okay. So that's cool, but I have a lot of fields that I actually don't need, right? Including the message field itself. I don't need it anymore because I have now the structured data that I want. So I can add a new processor, and this is the remove processor, and I can tell what are the fields that I want to remove. So there is the timestamp that I don't need. Okay, I don't need the input, I don't need the SAS, the host, the agent, and I set the message. Okay, let's add this processor. And let's have a look. Okay, so it's looking now better. It's better, but it's not ideal. Because here I have strings here. I don't have numbers. So what I need to do, I need to convert those strings to numbers, to floats. So let's do that. I can add a new processor. The name is convert. So I want to convert location.lat to a float. Yeah. And I can, by the way, duplicate this one, edit it, same for longitude. Okay. View. Okay, I think we are in a good shape now. So we can probably start to index some documents. So I'm going to save first the pipeline. Yeah. So this is, by the way, the list of the processor, what is generated behind the scene. You can do that obviously in the developer console, but I wanted to show you that you can do that with the UI as well. So nothing really super interesting here. So what I need to do, I need to go again to here, and I'm going to remove my Bano test. And what I'm going to do, I'm going to actually head, you remember the first 10 lines of my dataset, and use curl JSON, which is going to send that to 5-bit. Want me again to smile and to pause? And no, that's okay. So I did something. I think it happened. If I look at the, yeah, I can look maybe here. Yeah, so probably the data were sent. Let's look at the data that we have. So if I'm looking at what I have, indeed, I have my first 10 documents, exactly what I'm expecting. So Elasticsearch is about search, and we want now to search in this dataset to see if everything is okay for our use case. So the first use case that I have is that I want to search, for example, by a street name. Here, let's say Cormay, I have this name in the street name. And if I'm searching for that, okay, I can see that I have 2 documents, which has the Cormay terms in the street name. Cool. With Elasticsearch, you can also search by distance. Let's say that I have a user who is located at those coordinates, and I want to search for all the documents that I have within a 1 kilometer radius, basically. So let's run that. It's failing. Why it's failing? So I have here the information. It's not able to find a geo field name location. So let's have a look at the mapping. If we look at the mapping that we have here, we can see that Elasticsearch is actually generating automatically a mapping for us. I did not say anything to Elasticsearch, I just push data. And sometimes, I would say often, Elasticsearch does not take the right decision. So you need to fix your mapping. You need to provide your mapping. It's super nice to start with, but then you really need to provide your mapping. And one of the things that I here can see is that location is indeed, it's not a geopoint. It's an object which contains 2 other fields, lat and long, which are floats. And this is not what I want. I want location to be a geopoint. So to do that, I'm going to create an index template. Where is that? Here. So in here, you can go also in index management, and you have the index templates. What I want to do is to create a new template. So I'm going to call it Bano. So that's the name of the template, and I want to apply that to every index which starts with Bano, actually. So next. In Elasticsearch, in the most recent version, we have what we call component templates. Sorry, and those are building blocks that you can use to actually create your template. So I want to add this one. I already did that in previously. So I created two component templates. I'm going to show you exactly what it's inside. So inside this one, I have only index settings. And in this one, I have mapping and index setting. So if I'm looking at this one, what I have as settings, I just have the number of shards that I want to use with Elasticsearch. This is a good practice. By default, it will be one shard and one replica. And because I have only one node, it's not going to be replicated, and my cluster will be yellow instead of green. So here I want to use 0 as the number of replicas. And for the mapping, I have settings, and here I'm providing what we call an analyzer. Not going to cover that into details. If you attended my session, my previous one, I was covering a bit what is happening behind the scene. But basically, I need an analyzer for street names, and I need an analyzer for city names. The reason I needed to create explicitly something is because I'm using French cities and French street names, and we have some diacritics into the text. So I need to convert to ASCII my document to be consistent across the data set. And we have also elision to apply. And I'm also using synonyms here. Synonyms here, when I have BD in my data set, it means boulevard. When I have AV, it means avenue. When I have R, it means street. And RTE means road, right? So I need to do this transformation to be consistent everywhere. And then, I'm sorry, I forgot the mapping, obviously. So now I have this address, so I'm setting the address, the zip code is a keyword, the number is a keyword, meaning that I'm not going to run full text search on it, but exact match, I would say, or also filtering. For the city, I have this analyzer for the cities, and for the street name, I have this analyzer for the streets that I mentioned. And look, my location field is now a geopoint. Okay, this is what I want. So let's do next. I don't want to set anything. You could set also fields, settings here directly, but here I just want to create a template. Okay, so I have a template. And let's go to indices. I have my Bano test somewhere, just to show you that you can actually remove your index from here as well, as you want. Okay. So let's index again some documents and see if we are now able to cover our use case. So I'm going back here to this window. Head. Okay, I still have the same data set as previously. And here, so let's check the mapping. Okay, I have the right mapping. So it means that the template that I created have been applied automatically to because the index name was matching Bano star. So now I can still search, I guess, for street name. Yeah, it's still working. And if I'm searching by distance, okay, now it works. Okay, so I do have my the result that I'm expecting. So we can index much more data, and to do that, I'm going to change actually file bit. Sorry, of course I did that. So here, I don't know if you noticed that, but here I have also another input for file bit, which is a log type. Log type means I'm going to stream all the lines that I have in my files. So what are the files? All the CSV files. And it was disabled, but now I want to enable it. Okay. So I need to restart FileBit here. And I'm going to remove that because it's going to generate too much logs, actually. So it's starting to harvest all the CSV files. So this is all the lines that you are seeing here. This is the harvester for all the CSV file. And if I'm going here to Bano and counting what I have, so I have that number of documents, and this is increasing. Okay, this is still working. Okay. So obviously, I'm not going to wait. It took me a lot of hours to index all the datasets. So I have already indexed all the datasets that we need for the demo here. So I have 22 millions of addresses, which are the kind of postal addresses that I had when I created this. Maybe, what time is it? Okay, how much time do I have? How much time do I have left? Okay, almost 15. Okay, so I need to be faster. So I'm going to open directly a dashboard. So let me do that. So with Kibana, I said you can do some command, you can have variety of use cases like observability, security, all that is data after all, so that's okay. But here I have my Bano dashboard. So this is a dashboard that I built which represents my 22 millions of addresses in France. And so almost 23 here, and you have here the representation of this data set. So what you can see here is a map, and then here an aggregation by a count, sorry, of the number of addresses, and an aggregation by the number of cities that I have, and I have that number of region or departments, and those are the most popular departments that I have. And if I'm searching for Myrtille, for example, or Allée des Myrtilles, yeah, Allée des Myrtilles. So I have plenty of them, as you can see, and I'm living here in the 95 department. So I'm doing like a deep, what do you call that? Drill down. Sorry, I was looking for the name. A drill down here. And this is the city where I'm living, and basically, it's okay. So I'm living here. Hello. So I have this data set now, and what I can do with that. So I have actually another, no, sorry. What I want to show you is here how I can search now for addresses. So I have those 22 millions of documents. By the way, I'm going to stop FileBit because I don't need it anymore. So here I can search. Let's say that the user is entering this address where you have the number, the street name, you have the city name, you have all those things. And what I want to search for this in those three fields. And if I'm running that, I can see that I have that number of documents which are coming back. Why this? Because I have all the address which has a 6 inside, all which are in Sergi, all which has this term day, and all who have alley. So that's the reason I have all those documents. But the important thing is the score here, and Elasticsearch is sorting by the score by default. And here I have the most significant data that I want, and that's exactly what I'm looking for. This is this address. If I'm changing the size here, just so you know. So the second address that I have in my list, which is less relevant, is this one, 6. This is not the same city name, but this is 6 Allée des Myrtilles and in another department. Okay, so I have something else, but less relevant. Okay, and I can do the same thing by searching by geopoint. So let's say that I have a user somewhere, and I want to see what is the closest address to this user. So I have this point, and what I'm doing, I'm going to do a sort by distance instead of sorting by relevancy, around this point. So it's taking like 1 second, which is a lot actually for Elasticsearch. And it's giving me the closest address that I have, right? And this address is 3 meters away from the point that I gave, okay? And if I look at the second one, it should be my neighbor. Yeah, exactly. And this one is 17 meters away. Okay, but it takes some time to compute that. Why this? Because I'm doing this sorting on 22 million documents. It's not efficient at all. Here, for my use case, I know that I'm searching an address within an area, and so I can filter actually first by distance, and doing this geodistance filter, we saw that already, and then do the sorting. So instead of having to sort 22 millions of addresses, then I can just sort that number of addresses, and now it's taking only 80 milliseconds or so. Okay, but I still have the same result set. And because I created one index per department or per region, then I can do another optimization, which is with the zip code, I can extract the value and I can know in which department actually is my user. So I can even, instead of calling and searching into 99 shards, which are the internal details of Elasticsearch, then I can search instead in only one of them. So it's only 2 milliseconds now, okay, to search for this address. Okay, so we can apply that to a dataset that I have. I have a dataset that I have already indexed, so I have 100,000 documents, and if I'm looking for those documents living in Sergi, so those are the data that I have. So I have that number of people living in Sergi, and those are the documents, the content. So I have the name, the date of birth, the gender, the children, the address. You see, I have the city. I don't have the address. I don't know the street name. I don't know the number. I don't know anything about this user. I just know that this user is located here. So this is a random data set actually. And so I'm basically generating inside a rectangle around Cergy-Pontoise, the city where I'm living, the points, the geopoints inside. So what can I do with that? I'm going to start this because it's going to take a lot of time. And while this is starting, I'm going to explain what I'm doing. So I am using here Logstash. I mentioned Logstash is an ETL. And with Logstash, what I want to do is to use this configuration. So as it's an ETL, there is 3 stages, I would say. The input part, the transform part, the filter part in Logstash term, and the output part, the load. Right? So we have extract, transform, and load. So what I'm doing here, I'm reading the data from Elasticsearch. And I'm reading in my index name person, the one I introduced just before, and I'm searching for people living in Sergi, so exactly the query that you saw previously, with some kind of optimization here. I'm sorting by _doc. This is an optimization for Logstash to be faster, so you should do that, by the way. And then some information, I need the document info and blah, 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 what have you. And then for each document that I have in my dataset, so my 6K documents, more or less, I'm doing a filter. So I'm going to do a lookup in Elasticsearch. And now I'm going to look in my Bano star indices, right? And I want to run this query. What is this query? It's exactly the query that we saw previously, where I'm injecting the address location.lat, which is coming from my person dataset, from my event. And I want to do first a filter by distance of 1 kilometer to reduce the number of data that I'm going to work on. And then I'm doing this sort by distance to get the closest document that I want. And I just want to keep the first one, which is the closest location. Okay. Then with that document that has been enriched, so I'm doing here some transformation and removing again the fields like we saw in the pipeline. Some of the fields I don't need. Then I'm writing to Elasticsearch. So I'm reading from Elasticsearch, transforming with Elasticsearch, writing to Elasticsearch. Yes, I'm a bit Elasticsearch-centric, I know. So here, what I want to do, I want to index my new document that has been enriched into an index named metadata index, which is person, actually, the name person. It makes that flexible. And I'm just appending -new here, okay? And I'm using the same ID of the document. So let's have a look at what happened. Yeah. So I'm going to check in my person new index. here I have this one. Okay, I'm not yet there, so it's still coming. I hope it's not broken. Yeah, apparently it's still working. So it will take some time to run it. So let's do a search again. So if I'm searching for my data, so this person that I saw probably previously, I still have the address, the country, the city. By the way, you can notice something. The city is not Sergi anymore. We will see that in a moment. But I have the number, and I have the street name, and the zip code, yeah, the zip code, and all those things. And the location here is here, right? And I have that for all the other documents. So for this one, for example, it's still in Sergi, and blah, 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 what have you. Okay, how much time do I have? 7. Plenty of time. Okay. So let me build something cool. I can go to maps here in Kibana, and I can create a new map. And what I can do, I can add the layer, add my documents, which are coming from person. So the original data is here, and I can add that. Oh, yeah. I can add some things like the name for the tooltip and things like that. Okay. Just doing that easy. Keep change. And I can add the new layer with my new documents and my person new dataset and add and continue. Yeah, done. Okay. Close. So here I have on the same map, you can see that, all the things that I want. So I'm going to actually scratch that just to show you that how you can actually build your map. It's super easy. You just drop the fields inside the map. I do have a dashboard which is containing already the map and all the things that I want to show you. So I don't have the full dataset yet, but you can see that it's still coming. It's taking a lookup for every single document that I have, so it can take a lot of time. But what is interesting here, so is the representation on the map. So on the left, it's the not corrected dataset, and on the right, it's the corrected dataset. And if I'm zooming here, you can see that I am in the middle of the lake, which is obviously wrong. If I'm taking this person, for example, this person cannot live here. So what I can do, I can click here actually, and to see here, filter by this data, and I can see that the closest address for this person is here. So this is Rue de Vauréal, and blah, blah, blah. Okay, so that's cool. Also, what I can see here, for example, you can see that I have here a city name, Boisemont, and another city name here. Why not? If I'm looking at this value, this person is in Sergi. That's the city name for the source dataset. But because I'm using real data to do my enrichment, I can correct automatically. I know with this geopoint that actually this person is not in Sergi, but this person is in Boisemont. Okay, you can see that. So you can see the source value and the corrected value. Okay. So I think that's all what I have for today. What I wanted to show you. Oh no, I forgot. So I closed the. Sorry. I closed the GitHub repository, but I think I can find that here. GitHub. Yeah. Bano, I think it's the name. Okay, so you can check out this repository if you wish. By the way, I'm David Pilato. I did not introduce myself. And I'm developer evangelist at Elastic for 11 years almost now. So check this out, play. I know that you have some use cases here with the postal addresses, so maybe that's interesting for you to use that kind of features of the stack. And feel free to use that and reach out to me. I'm Dadune on Twitter, so I will have the link posted on Twitter as well. I can just show you that. Twitter. Yeah, and I'm here. That's my name. You can follow me on Twitter and on LinkedIn. Thank you. Have a nice day.